So we are starting Unit 5, and that's going to be all about gases. We talked about solids, liquids, and gases so you could see the difference between the particles, and so that we could talk about kinetic molecular theory, and so you know what's going on with the particles within gases. So now we're going to talk about a lot of their properties. And Section 1 is all about the gas laws. And the first gas law is Boyle's law, and it relates pressure and volume. And it says that the volume of a fixed amount of gas held at a constant temperature varies inversely with pressure, which simply means that volume and pressure have an inverse relationship, which means as one goes up, the other goes down, which you can see from my picture here with the graph. As we follow along with volume along the bottom, as you go from left to right, you can see that the line is decreasing, so the pressure is decreasing as the volume is increasing. And I've also included the equation for Boyle's law right here, which is extremely important. We're going to be using it quite a bit. So Boyle's law has P1V1 equals P2V2, where the 1 indicates initial pressure and initial volume, and then the 2's indicate the new volume and new pressure. So here's an example of why Boyle's law works the way that it does. So you can see that as pressure is added inside this canister, in other words, they push this plunger down, the particles are going to be pushed closer and closer together, and within a smaller space, they're going to strike each other and strike the sides of the container more often and with more force, which causes more pressure because we know particles running into the sides of a container is what causes pressure. And once again, you can see this graph of that inverse relationship. And then here's a practice problem with Boyle's law, and I'm going to change it up a little bit this time. I'm going to let you guys try this in your notes, but I am going to tell you what the answer is. So I want you to work through it and see if you can get the correct answer. And if you're having a hard time doing that, then I want you to ask specific questions about what is giving you trouble when we get in class together. So go ahead and write down this practice problem, try it for yourself, and the correct answer is 1.6 liters. So we can have a discussion about it in class together. So go ahead and try it in your notes and see if you can get this answer. Our second gas law is Charles' law, which relates temperature and volume, and says that the volume of a given amount of gas is directly proportional to its Kelvin temperature when the pressure is held constant. So in other words, volume and temperature have a direct relationship. So as one goes up, the other goes up. And it specifies that the temperature, when put into this equation, must be in kelvins. And that's true for any gas law. So to convert a temperature to Kelvin, you take your Celsius temperature and add 273.15. And Kelvin is different. Kelvin is not in degrees, so like we would say degrees Celsius or degrees Fahrenheit. When it's Kelvin, it's not degrees. It's just the number and then Kelvin. And then 0 on the Kelvin scale is also known as absolute zero, which is where the lowest possible theoretic temperature is. So that's where you have the least amount of kinetic energy possible. And that's why it works for the gas laws. And then, as you can see, the equation is down here at the bottom. V1 over T1 equals V2 over T2, and the 1's and 2's represent the same things as they did in the Boyle's law. So you have your initial volume and temperature set equal to your new volume and temperature. So here I have the graphs, and you can see the direct relationship between volume and temperature. So if you look at the bottom graph, which uses Kelvin temperature, you can see that as I go left to right and the temperature is increasing, the volume is increasing as well. And then as far as reasoning goes, since we know what the particles are doing, if we increase the temperature, it's going to cause those gas particles to move faster and spread further apart, right? Which means that they are going to take up more space and more volume. So it makes sense. And so here's your practice problem for Charles' law. And we're going to go with the same thing. I'm going to go ahead and tell you what the answer is, and I want you to go ahead and see if you can put these variables in your equation and solve to get this correct answer, and we'll talk about it in class. So the correct answer is actually 2.58 liters. So go ahead and give it a try. Our third law is Gay-Lussac's law, and that relates temperature and pressure of a gas, and says that the pressure of a fixed amount of gas varies directly with the Kelvin temperature when volume stays constant. So he's saying that the pressure and temperature of a gas have a direct relationship as well. So as pressure goes up, temperature goes up. As temperature goes up, pressure goes up. So that means that your equation is going to be P1 over T1 equals P2 over T2. And here you can see why, when we take and increase the temperature of the gas particles in this cylinder, so like we do in the right-hand picture, the speed is going to increase, the space between them is going to increase, and they're going to strike the sides of the container harder, which increases the pressure. So the direct relationship is reflected in that graph. As temperature goes higher, so does the pressure. And then here, once again, is your practice problem for Gay-Lussac's law. So I want you to go ahead and plug in your variables and see if you can go ahead and get your correct answer, which for this problem was going to be 4.4 atmospheres. So go ahead and give it a try. So the last gas law is the combined gas law, which simply just combines all of the previous laws and states all of the relationships at the same time. So if you have this, you can figure out all the other ones. So we have P1 V1 over T1 equals P2 V2 over T2. And given some variables, we can figure out a lot of different things. So here's a practice problem for the combined gas law. So go ahead and give it a try as well. And I'm going to go ahead and put the correct answers on here, but I want you to spend some time working through them and making sure that you can at least attempt to get your math correct to get your right answer. So what you should get is 0.58 liters for your answer. So go ahead and work on it and try to get to that answer. And we will do some more practice when we get back to class.